Hi everyone, I'm just going to do a quick little video at the end of the day. Everyone's asleep, so hopefully I'm not going to wake anyone up. I'm going to talk about partition views and glyphs just to finish off this particular talk. Now, when we're talking about partitioning a space, it just means splitting our data up. Now that could be splitting up somewhat arbitrary, that's not that useful, but frequently it's by a particular key, like your student IDs, and then you group them based on the starting number, for example. It could be based off of, who has, or the value of an attribute might be who has the 80% in the class, who had 70% in the class. You can split the groups up in various ways. And that means that you don't have to have all your data all in one place. You could actually make different views of the data based on these partitions. How we divide up that data changes how a given hierarchy, how we drive up that data changes how we view things. And you may have a hierarchy of different attributes, how you want to split this up. You can have many splits, the order of splits, you can look at a whole bunch of different views. It really depends on the circumstances that you're dealing with. Most of it's data driven, but it just means what we're talking about is we could have a hierarchy in how our attributes look. We can split it up somewhat arbitrarily. The idea is parsing of your data and then grouping it in particular ways. There's a wide variety of things you could do, which brings us to this. So this is not how we would actually split up our data, but it's just going through the idea of what we mean by partitioning. So if you took hello class, this is an example, as a piece of string, a string of text, how many ways could you break that text up into different groups? For example, you could do vowels, consonants, and punctuation as a group. You could do in the order of the alphabet. You could do groups of it, so A, B, C, D, E, F as groups in the alphabet. You could do all sorts of different things. So I would like you to just quickly doodle down a whole bunch of these examples on a piece of paper is fine, or in a Google document is fine as well, and throw it into another file for L12. Right? We already have a file in L12, but you can add another file in L12. And it's just how many different ways can you parse this? Unique ways. Can you parse and partition this string? Hello class, this is an example. It's surprisingly large number of different ways you can partition this thing. And that's sort of the point. Okay. So once we've partitioned our data, now we have to worry about something else. Do we partition the entire region or a particular part of it, like a view? And take the entire view? Do you want to do a little part at a time? How do we want to break this apart? And I also like to point out that glyphs, the definition of a glyph, which we're going to talk about now, is it's somewhat open for debate. There's not a very clean definition here. There's the difference between a visualization and a glyph is somewhat nebulous. It is normally, I have a data item, I want to show a whole bunch of attributes for that one data item, but I could have a whole lot of data items and all their attributes, and then it would be an aggregate item. Better to look at an example, but it also comes very, very close to a mark. So we have a view, which is how we look at our data as one big, like a line graph. We have marks, so if you have a scatter plot, each dot, what does it represent? A glyph is sort of that part way, which is I can encode a lot of attributes on that dot, or make a dot a particular shape, or make it a bar, and the length of the bar means one thing, the width of the bar means another thing, the color of the bar means another thing. A glyph is normally just encoding a lot of attributes typically for one element. And we have microglyphs and macroglyphs, macroglyphs being large, like one big glyph. Microglyphs would be something like this. These are microglyphs. This is technically a glyph. It looks like a bar chart, but it's for one data item, and I have a whole bunch of attributes for that data item. Or each of these for a tensor field. Each one of these things is representing one item, but it's encoding a whole lot of different attributes all at once. They hover on the faces, so the different faces and what they represent, encoding attributes all at once. Pie chart, little mini pie charts, or little stars that star charts that you can do. So you can do something like, hold on, out for a second. If this is my data point here, I maybe have length here. This. If each one of these lines is an attribute, the data point is in the center, that would be a glyph. I could line it up. That's a glyph. There's a whole bunch of different things I can do. The idea is it's one of the options you can have to represent a whole lot of data about one particular attribute, about one particular item, called a glyph. So here would be examples of a glyph. So this is a single bar chart with grouped bars. So they're grouped bars. Groups of 7 would normally represent a glyph, but it's still a bar chart. But this is for New York and all the attributes for New York. This is Florida, all the attributes for Florida. Versus this, our region is something like this, all these values here. And we have different regions that are, and different groups that are aligned to each other. Same data, just represented in two different ways. So speaking of glyph, I'm not going to do the Hall of Fame or Shame because it's actually really fame. You might disagree. Technically a glyph. Every single note that you actually encode music with, technically even writing is a glyph, but it's a different, doesn't really encode a whole lot of attributes. But if you look at notes that you're playing here, not only are you encoding information on the position in space, but different parts of the note actually are representing different things. So the difference between an 8th note and the 16th note is this extra little tick in there. And we can actually encode where it is on the staff, also encodes the tone that you're actually going to be playing. So we have time, we have grid lines, we have frequency, and it's all binded together. I think as a set of glyphs, it's kind of amazing that this actually works as well as it does, and how effective it is, because although this is Twinkle Twinkle Little Star, many of you, without looking at the bottom of the screen here, can actually read this and tell me what song that is without actually looking at what is being played. That's amazing that glyphs can do this. Okay, so we've looked at glyphs, we looked at multiple views, we looked at overview plus detail, we looked at brushing and linking, we looked at a whole lot of these different interaction techniques and how we can filter out data for ourselves and different views of the data. So next time around, I think we're going to do user evaluations just to make sure that's done and out of the way, and then we can look at other visualization topics, maybe the ones you haven't even thought about, and I'll poll the class to see what kind of topics you're interested in, like digital storytelling, data storytelling, or maps, or 3D visualization, so scientific visualizations. So that's something to look forward to. All right, thanks everyone.